Number 7 is asking us to change this expression in the form ax minus h squared plus k. So we're basically completing the squares. And the reason we do this, based on the use of the word hence, is I guess it proves useful in question B, where we have to perform this integration. So let's get on with A. So minus x squared plus 2x is going to be minus x squared minus 2x. And if you want to complete the squares, we want a +1 and a -1. So we're essentially adding a 0 here. So we're not really changing the expression. But what we can do now is we can take the -1 outside of the bracket. And before we take it outside, we multiply -1. So we have minus x squared minus 2x plus 1 and minus -1. So it's a +1. So that's going to give us minus x minus 1 squared plus 1. Next, in B, we are finding the value of this integration. So what we can do is we can make the substitution from A. So we have integrate from 1/2 to 3/2 1 over 1 minus x minus 1 squared, square root d of x. And if we make the substitution, u equals x minus 1, then differentiate both sides, du equals dx. Also, when x is 3 over 2, then u is going to be 3 over 2 minus 1, which is 1/2. When x is 1 over 2, u is going to be 1 over 2 minus 1, which is -1 over 2. So we can rewrite this using substitutions as 1 over 2, -1 over 2, 1 over square root 1 minus u squared du. And if you refer to your formula booklet, you know that the integration of this form gives us arc sine u. So we have arc sine 1/2 minus arc sine of -1/2. This gives us pi over 6 minus pi over 6. That's going to give us pi over 3.